Hi everyone, I'm Valerio, CTO of Inspector, the company behind Neuron AI framework. And in this video, I would like to guide you in a practical example of developing and monitoring an AI agent using Neuron and Inspector. The goal of this tutorial is to show you how easy it is to integrate these kind of agentic components into an existing PHP code base. It's important because it's one of the most important problems that Neuron was designed to solve. And Neuron was born as an internal project to create the AI bug fix integrated in the Inspector monitoring tool. And 2 months ago, we decided to release this module as an open source project because we thought that its design could be really, really helpful for PHP ecosystem to fill the gap with other technologies when it comes to AI agent development. You know that a lot of things are going on in the Python ecosystem, for example, and I believe that projects like Neuron, backed by a company with real business interest for the long term, it could be a trustable platform for other companies to start their journey in AI agent development in PHP. So if you want to know more about Neuron, you can check out the GitHub repository. Also, take a look at the documentation when you can find some guide on how to get started and also understand all the other framework components. And well, I switch to my PHP storm so we can start coding. In this tutorial, I will use a Laravel application to help me simulate an existing code base. Laravel here is just an example. It can be the same if it is a Symfony application or other frameworks. So first we have to install the Neuron AI package, Inspector APM, Neuron AI. Once the package is installed, we can create the Neuron namespace into the application structure. Having a dedicated namespace, it's important because allows you to work on your AI agent implementations as separated components that you can later use in other parts of the application. So let's start creating the YouTube agent class. YouTube agent. So we can correct the name YouTube agent. Just extending the Neuron AI agent class, and the only required method you have to implement is the provider method. And here is where you can define the connection with the LLM you want to use. Let's assume is Anthropic, but you can also use OpenAI or Google Gemini or running some models locally using Ollama as a provider. To instantiate the provider, we need to pass some arguments like the API key, obviously, and the model we want to use. We can get these parameters from the application configuration. For example, in the Laravel application, we can create a new item into the services configuration file specific for Anthropic, where we have the key and the model we want to use, always getting the value from the environment file, but we can have also a default value for the model as Claude 3.7 Sonnet latest. I already have these environment variables into my environment file. So I can switch here to the agent class and pass this configuration properties service Anthropic key, and for the model service Anthropic model. The second most important building block is the system instruction that you can define implementing the instructions method. And we return an instance of the system prompt class from framework. This kind of prompt is weighted many times more than the normal input messages you send to the agent, and it allows you to focus the agent behavior toward a specific task or role. The system prompt class specifically is designed to take your base instructions and build a consistent prompt for the underlying model, reducing a bit of effort for prompt engineering on your side. I already have an example of a system prompt for this implementation we are working on. Just format the code a bit better. So basically, the system prompt takes three arguments. The first is the background, where you can write about the role of the agent, describing the macro task it's intended to accomplish. The second argument is steps, where you can define the way you expect the agent to behave. And the recommendation here is to describe your needs in multiple steps, because it helps the agent to act consistently. And the third parameter is the output format, where you can define how you want the agent to respond. So the format of the response, you have to be explicit on the format you expect. We are now ready to talk to the agent to be sure we are making all right. So I create a new artisan command, make command agent. In this command, we can just send a message to the agent and print the response in the terminal. So we can create an agent instance and call the chat method, passing a new user message, and we can ask, "Hi, who are you?" and just echo the response content. We can run this command, php artisan app agent, and the agent respond, giving us some information about his tasks, etc. So this is a basic example to demonstrate how easy it is to use an agent inside your app once you have created your implementation. Consider that an agent can become very complex, using also tools, vector database to access external knowledge and other components. Before moving forward with the implementation, I'll show you how to connect Inspector to your agent in order to monitor what happened during its execution. Inspector will help you better understand what's going on inside your agent, and it's one of the best way to understand the underlying implications of what you are doing as you add more and more features. Inspector also will alert you in real time if something goes wrong in your code. Connect the agent to your Inspector account is really simple, because you just need to put the Inspector ingestion key in your application environment file. And once this key is the environment variables, the agent automatically detect the key and start sending data to your Inspector dashboard. We can run now the agent again. So PHP artisan app agent, and go to see the data in the Inspector dashboard. In the Inspector dashboard, we can see the Laravel command executed just a few seconds ago, and we are able to explore the timeline of this command. Inspector automatically detects the agent execution and trace all the internal steps. So we can see here the action the agent performs to complete the task, with also some context data attached, like the messages, the content of the system instruction here, the provider that you configured, etc. Now, to be able to create the summary of a YouTube video, the agent must be able to consume the content of the video we submit. So we need to give the agent the ability to retrieve the video transcription. So we need to give the agent a tool to do so. So back to the agent implementation, we can implement the tools method that return an array of tools. Neuron provides you with a tool class to specify what the tool is about. So we can add a tool to this array. Just to show you an example, in the constructor we can assign a name, get transcription, and the description, retrieve the transcription of a YouTube video. And it allows you to define what the tool is about, why the agent should use this tool. And for this example, I have just a bit of code already implemented. So we can just reformat a bit. We can add to the tool some property. In this example, we expect the agent to call this tool using the URL of the video we eventually submit. And the callable function should contain the actual code to perform the action we want and return the results that Neuron automatically return back to the agent to finally receive the response. For a better code organization, I create a dedicated class. We name get transcription into the same namespace of the agent. that is dedicated to interact with an external service. In this case, I'm going to use Supadata, that it's basically an API service that allows you to retrieve transcription of a video just providing a YouTube URL. And this class implement the invoke PHP magic method with the same signature we defined here. So we can just change this statement with providing the instance of this class. It will be automatically used as a function because it implement the invoke magic method. To make this service work, we have to configure the Supadata key. So in the services configuration file, we can create a new service. Oh, sorry. Supadata with the property key. We always get this property from the environment file. Now we can change the message sent to the agent, asking for a video analysis. So I really get this example video from YouTube, and we can run the script again with the artisan command PHP. Oh, sorry, up agent. Just wait some second to make the agent able to complete the task. As you can see, the agent is effectively able to create the summary of the video. So let's go to the inspector dashboard to understand what's happening inside the agent. If we open the timeline in the inspector dashboard, we can see that the agent responds to the first message with a tool call request. Neuron basically execute this tool and return the result back to the agent to get the final response. That is basically the summary of the video we submitted. So in this timeline, it's clear to understand each steps, what is going on behind the scene, the tool call performance and memory consumption. So because it's basically a mix from calling external services to running something inside your application code. Thanks to Inspector, if something goes wrong during this process, you will be also alerted in real time with a detailed report of the error. We can eventually simulate something broken in our code, just firing an exception here in the get transcription class. Exception test error. Run the script again. And now the agent takes some second to call the LLM. The LLM respond back to the agent with the request to execute the tool. Neuron try to execute the tool, and here is the exception. So we can now go to the inspector dashboard and see the report. In the transaction list, we can see the command result labeled as error. And in the errors tab, we can explore the errors reports. Here is the instance of the error we fired just before. The inspector try to help us identify the part of the code that is firing the exception, so you can basically understand the actions you need to fix it. Okay, we are at the end of the tutorial. I hope it can help you start implementing AI agents into your PHP projects. And remember, start small, monitor your agent during implementation to better understand its behavior, and gradually extend its capabilities as you get more comfortable with the underlying technologies. I know that a lot of things are quite new for a lot of PHP developers. So thanks for watching. If you have any questions, you can create a post in the discuss section in the GitHub repository. And if you found this tutorial helpful, please like, subscribe to get more content on integrating AI agent into your PHP application. Check out the description for links to the code of this tutorial and also additional resources for Neuron AI and Inspector. Thanks for now.